Hi everybody, we're continuing with Chapter 2 notes, and we've gotten through displacement and position and velocity, and now we're at the concept of acceleration. This might be a little more, I don't want to say confusing, but it has tripped some people up until you really understand what it is. Acceleration is a rate of change of an object's velocity. If you go back to think about what velocity is, I'll write this in here, velocity is a change in position over time, right? Well, what acceleration is a change in velocity over a corresponding change in time. And that's what our equation down at the bottom says right here. Our average acceleration, and we're really only going to be dealing with constant accelerations this chapter, so you don't even really need to worry about a non-average acceleration. An average acceleration is a change in velocity over change in time. Since velocity is a vector, that makes acceleration a vector, so it's got a direction. You can have a positive acceleration, or you can have a negative acceleration as well, but both positive or negative accelerations are accelerations. Just like velocities, you can have a positive velocity or a negative velocity. Either way, it's still a velocity because it's direction dependent. And if there's a sign out front, it will tell you what the direction is. We're assuming it's on some sort of pre-established coordinate system. So if there's not a negative out front, then that assumes that's the acceleration. If there is a negative out front, then that means the acceleration is that way as well. So let's look at this equation for a second right here, and we will identify the units that we use for acceleration. Acceleration is a change in velocity over a change in time. All right, well, velocity, draw my line right here, the velocity is in meters per second, right? That's our standard unit of measurement for velocity. And it is how far you go or how far you're displaced in a certain amount of time. Well, acceleration is a change in velocity over time. And so this is our velocity or change in velocity right here. And so put that over time. Time is measured in seconds. So you can say it's meters per second. And what that simplifies down to is if you take this second and bring it up right here, it really winds up being meters per second squared. And that's where that comes from right there. Meters per second squared or meters per second. For example, if I have a car right down here at the bottom right here, a very horribly drawn car, it's going to start at rest. All right, so its initial velocity is 0 meters per second. But it's going to accelerate. All right, and here's the ground right there. And so somewhere down the line, it is going now, let's see here, at 1 meter per second. So it's got a different velocity. Further down the line, all right, it's going at 2 meters per second. So it's not just further down the line, it's not just displaced, but it's also traveling faster. Further down the line, as it continues to accelerate, it will now be at 3 meters per second. So it's not just being displaced, which it is. It doesn't just have a velocity, but it has an increasing velocity. We would say that this is increasing. Let's say this is 1 second right here, and this is 2 seconds, and this is 3 seconds. So for every second that elapses, 1 second, 2 seconds, 3 seconds, the velocity changes by a matter of 1 meter per second. So after 1 second, it's got 1 meter per second velocity. After 2 seconds, it's got 2 meters per second velocity. After 3 seconds, it's got 3 meters per second velocity. So it's increasing at a rate of 1 meter per second every second, or 1 meter per second squared. That's how we would describe that acceleration right there. An acceleration could be positive or negative, like I said. And it also means you can have a deceleration as well. The speed might decrease over time, but you're still having an acceleration. For example, let's say we have a car right here, all right, and it has a the velocity is 2 meters per second. Okay, and then something happens to it. Maybe it hits a rough patch on the road right there, and then later on it comes to rest, and the final velocity equals 0 meters per second. So an acceleration has been applied to this car right here. The acceleration really has come in the form of this gravel or this bumpy area, applying a force to the car and slowing it down. So the speed is decreased from 2 meters per second down to 0. But really, this bumpy stuff right here has applied an acceleration, even though the moving object has come to a stop, as the speed is decreased over time. So the point here is all decelerations are accelerations. They're just in the opposite direction that your initial object was moving. And it is possible for an object to have a positive acceleration and still decelerate. And we'll talk about that on the next slide right here. All right, so all these are the various different possibilities that you could have with an initial velocity and some sort of acceleration right here. Well, this first one right here is pretty straightforward. This says that if you got no initial velocity, if your object is at rest, and you have no acceleration, then obviously the object would remain at rest. Just like you probably sitting in your seat right now. You don't have a velocity, or at least relative to the room, and nothing's accelerating you, so you continue to remain at rest. What if, however, you have an initial velocity of 0, but you're experiencing a positive acceleration? That's what that means. That means acceleration is greater than 0. That means you're going to start to accelerate. So let's say you're sitting there in your chair, and I'm not sure I really want to draw this, but say you got a rolly chair, and you're sitting right there, and your friend applies a force to you, all right? Applies an acceleration to you. You start to accelerate in the positive direction. What if you have an initial velocity of 0, but you have you receive a negative acceleration? All right, well, you're sitting right here in your chair. That's your chair. You're sitting in there like that, and your friend comes along and applies an acceleration to you. That's your rolly chair. An acceleration to you in the negative direction. You're receiving a negative acceleration, but you're still accelerating. You're going from rest to some sort of motion. So you're accelerating, you're getting faster and faster, you might say, but in the negative direction. Okay? What if we have a velocity? We have an initial velocity greater than 0. That is, we're moving in the positive direction, but you experience no acceleration. That means, what if your friend has pushed you and you're moving across, I don't know, maybe you're sitting on some ice, and you're moving across the ice, which is virtually frictionless. You'll keep moving, and nothing is accelerating you or decelerating you. That means you're going to keep moving forever. Well, in the real world, even ice has friction. You will slow down. But say in space, there's absolutely no friction at all. You would continue to move at a constant speed forever until something affected you, until something applied an acceleration to you. All right. Fifthly, what if we have an initial velocity greater than 0? So we've got a positive velocity, all right, and we have a positive acceleration. That means your object moving with a positive velocity is going to start moving faster and faster and faster in that positive direction right there. So it's going to speed up positively. All right, what if we have an initial velocity greater than 0? Right there. But we have a negative acceleration. That is, the acceleration is being applied to you the opposite way. Well, think of it right here. Like, what if you were previously moving forward, but then all of a sudden your friend jumped in front of you and applied a backwards force to you, a backwards acceleration? You would come to a stop, or you would start to slow down. You'd be moving like this happily, and then something applies a negative acceleration to you, and you come to a stop just like that. That's what would happen in that scenario. You would decelerate and slow down towards a stop. What's the sixthly right here? 1, 2, 3, 4, 5, 6. No, seventh. Okay. What if you've got now a negative velocity and no acceleration? Well, that means you would continue to move negatively in the opposite direction forever because nothing is going to slow you down. You've got a constant speed. It just happens to be in the negative direction. Okay, you got a negative velocity right here. But you're receiving a positive acceleration. So let's say you're happily moving in the negative direction like this, but something applies an acceleration to you that's in the positive direction. So you're moving negatively, and then you're receiving that positive acceleration. You're going to come to a stop. Now, eventually, you'll probably come to a stop and start moving forward, but at first, you're going to just be moving and then come to a stop just like that. So you're going to decelerate. You're going to slow down in that negative direction right there, and eventually probably start moving positively. And lastly, let's say we have a negative velocity, negative initial velocity, and we have a negative acceleration. And that means you're starting out moving negatively like this, but something is applying acceleration to you in that negative direction. So even though you start up moving negatively, you're going to move faster and faster and faster negatively because you're going to speed up just in the opposite direction. You're going to be going faster, you're going to have a faster velocity, but it's going to be in the negative direction. So those are all the possibilities you can have between velocity, acceleration, and speed. And in the next video, we're going to take all these, or some of these scenarios right here, and actually apply them to some problems. We'll see you then.